Alright, so the final exam review guide for semester 1, we're going to do as much of it as we can in this video. It might have to be broken up a little bit. So if we look at this first question, atomic structure, just asking about protons, neutrons, and electrons. So the first thing it has is their charge. Alright, and if you remember my trick, protons start with P, so does positive. So protons are always positively charged. Neutrons are neutral, which means they have no charge. And then that means electrons, kind of the only thing left. Electrons have that negative charge, right? That's why they are kind of responsible for a lot of things. Then their location within the atom. So my protons and my neutrons are right in the middle, which is called the nucleus. All right, so both of those we find right there. The only thing we don't find there is the electrons, and the electrons are in the electron cloud. Or you could say the electron shells, lots of kind of those terms that we use. But electron cloud is the easiest to remember because it has the name in it, right? Electron cloud. So these two are in the same place. This is in a different place. Question 2, what two subatomic particles are added together to find the mass? The mass, I take the things in the middle, right? So protons and neutrons, they're the only thing that has weight. The electrons weigh almost nothing, so we don't even count them. So I have to add together my protons and my neutrons for that one. So if I add those two things together to find the mass, how can I find the number of protons? I could do the mass minus the number of neutrons. That would work just fine. Or, really the easier way, same as the atomic number. Right? My number of protons, that atomic number, are always the same. Regardless if it's an isotope, an ion, my protons never change. So if I change my protons, I change the element. So in this one, how can I calculate the number of neutrons if I have the mass and the atomic number, which is the number of protons? I can just do mass minus atomic number. And that'll equal my number of neutrons. Question 5, we have this chart. We filled these out quite a bit. So just a neutral atom. And if it's a neutral atom, that means my protons, my electrons are always going to be the same. So if I know one of these, I know the other. So those I can fill out right away. I also know that my number of protons is the same as my atomic number. So I can fill all those out. Right now I'm just left with a couple more things. Well, I guess in this middle row, right, if I say the atomic number is 20, it means my number of protons is 20, that means my number of electrons is 20. So that part's easy. Now I'm really just left with neutrons and the mass number. So mass number, I can just go right to the periodic table. And if I find that, I have it pulled up. So number 18 is argon, which is 39.9. We would round up the mass to 40. I'm going to put a 40 there. Right, then that all checks out. I could do 18 plus 22. That also is going to give me 40 to kind of check my answer. That leaves me with the mass of this last one. So I'm looking for atomic number 15, which is right here. Phosphorus, that's 30.9, which I will round up to 31. So this is a mass of 31. Last thing is the number of neutrons. Remember the number of neutrons, like I said up here, I can just do the mass minus the atomic number. So here I have 40 minus 20, which gives me 20. Here I have 31 minus 15, which gives me 16. And that's it. 6 is Bohr models, which I can't really draw on here too well, but I will post the answer key on Classroom. Just remember that 2882 rule, meaning so beryllium has its atomic number 4, which means it has 4 electrons. So I could fit 2 in that first energy level. My next 2 would have to move to the second. Right, so this just tells me how many electrons I can hold. But if you have questions on Bohr models, watch my crash course video or ask when you're back in class. Unit 3 then was isotopes. So if you remember isotopes at all, that is when I have the same element with a different mass. And I never change the number of protons, which means I must be changing the number of neutrons, which is all this first question is trying to get at. So isotopes of the same element have different masses because they differ in their number of neutrons. Write the hyphen notation for the most common isotope of chlorine. So first, hyphen notation, that's the name of the element, hyphen, its mass. If I want to know the most common isotope, I go to the periodic table. Right, so the number this is closest to is the most abundant or the most common isotope. So I have 35.45 as my mass. So 35.4 is what I'm going to put it at. So I would round to 35, which means I'm just going to write chlorine hyphen 35. That's the most common isotope. That's it. This next one, nuclear notation for the most common isotope of lead. Nuclear notation is where I write the symbol and I just swap the numbers. So my atomic number's on bottom and my mass is on top. Again, it's hard to type on here. I'll at least find the most common isotope though and put that number right here. Same thing, I'm going to go to my periodic table and find lead. It's 207.2, which I would round down to 207. So that's my most common isotope. And I would write that in its nuclear notation. Last question on the front page. The number of neutrons of any isotope can be calculated by, and this is a trick question because it's the exact same. Mass minus atomic number. That should still give me the number of neutrons, right? I might have different masses, so my number of neutrons might be different, but that's okay. I don't have to calculate it any different. And last question for isotopes, we have one of these tables. The trick with this table, I'm only going to do maybe like one row of it, I think you'll get the gist, is for isotopes, I don't want to take the mass on the periodic table because it's an isotope, which means it has a different mass than the one on the periodic table. So we have to calculate it a little bit more. So if I look here, it's still a neutral atom, which means my protons, electrons, and atomic number are all the same. So if I have 12 protons, I have 12 electrons, and I have atomic number 12. Number of neutrons, if I take the mass minus the atomic number, I would get 14. Then hyphen notation, the name hyphen the mass. So I have to find atomic number 12, which is right here, magnesium. So I will write magnesium hyphen, and then its mass is 26. And here's what I'm talking about. If I were to go look at magnesium on the periodic table, it is a mass of 24. So I might write, okay, magnesium 24, but that's incorrect because I told you we have an isotope that weighs 26. So you have to add the protons and neutrons, or subtract the mass and the number of protons to find your neutrons, or add these two numbers together to get the mass, but you have to kind of figure that out a little bit more. And for time's sake, I'm not going to do the other two rows, but you can check that answer key always. Same with alpha, beta, and gamma decay. These are a little bit more challenging to type out, so I'll talk through them, but if you want to see it written out, go check the answer key. So in alpha decay, I always lose a helium atom, right? Every time, that's how I know it's alpha decay. So I should have 4 over 2, He is my first element. And then to find this other missing piece, I just subtract the top numbers and subtract the bottom numbers. So I have 230 then minus 4, which should give me 226. 90 minus 2, which should give me 88. Then if I go to the periodic table and find 88, I would write Ra as my symbol. And that's an alpha decay. Beta decay is a little bit different. I'm actually going to stop here. The bell for school is about to ring, so we'll pick back up at 14 in the next video.